so the order of events here will basically be, I'll talk a little bit about kind of the background of our infrastructure and kind of what we're managing with configuration management, and then Mac will talk a little bit more about some of the kind of mostly people problems that we've solved around how we interact with configuration management. So if you were like hoping to get a like chef intro, this is probably not it, but we are going to talk about some of the like kind of interesting things that kind of happen at scale with configuration management. So hopefully it will be applicable even if you don't use Chef. So yeah, so I am an engineering manager in the infrastructure engineering team, and we're basically responsible for kind of the physical footprint up to user space, right? So making sure that the servers that we build and design are kind of they work. If you're a DigitalOcean customer, you're running on top of the platform that we maintain. And so there's a bunch of different kind of responsibilities that we have, which will kind of inform, kind of the rest of the talk. So we do, everything from hardware design up into user space is called platform. Then we have a security team and a networking team, right? So this is really kind of like all of the different pieces that are required to write and build software and manage configuration on top of, DigitalOcean. So this will be obviously more focused on the physical infrastructure that we have. So it won't be like as much about managing droplets, but it will be more about kind of the actual underlying hardware that we then virtualize on top of to provide droplets. So just to talk about our footprint, we actually have 10 data centers now. We decommissioned one, and I removed the decommissioned one, but I didn't update the number. So we have 10 data centers. We have 3 here in New York. We're about 10 blocks from one of them, and a little further from the other ones. We have 2 in Amsterdam, and then San Francisco, Singapore, Toronto, Frankfurt, and London. In terms of the kind of network interconnect, we have about 1,500 peers around the globe. If you're familiar with kind of how peering works, we basically have partner networks that we're physically connected to, and there are about 1,500 of those. We have 10,000 plus hypervisors. I can't talk about the exact density of those hypervisors, but they run hundreds of virtual machines each. Our global fleet has 1.2 petabytes of DRAM and about 50 petabytes of SSD currently deployed. So as you can see, like the footprint that we're dealing with has a couple of interesting features to it. One is a lot of memory and storage. Another is that we have kind of global distribution, right? So this is both a blessing and a curse. If you ever worked somewhere that's had 1 or 2 really big data centers, you know that there's kind of problems around how to interact with those really large data centers, and we're kind of lucky in that we get to use our smaller facilities to help roll out changes and help improve our systems more kind of globally. But yeah, this is basically what we're operating on. So this is what we're managing. Yeah, and also if you've what's that?
No spinning disks anyway.
There are no spinning disks, except in one case, which is for cold storage. But that's not really user facing, because SSDs for cold storage isn't really economically viable at our scale. I'll talk a little bit more about what that stuff looks like. Also, if you have any questions along the way, feel free to just raise your hand, and I'll be happy to answer them. So we have like a number of kind of design principles that kind of inform the infrastructure decisions that we make. So one of them is that data centers should be as hermetic as possible, which basically means services that run inside of data centers should be restricted to operating that data center only. This is a challenging one because we have some centralization problems around where we do initial scheduling, right? So, that's kind of a principle. So, right, we try to keep systems contained inside of single data centers as much as possible, which kind of limits the failure domain of a data center and helps kind of making changes to a system more easy because we kind of we have the nicety of being able to roll out new systems and new data centers one by one. A thing that we've kind of adopted in the past year is trying to get rid of as many kind of hardware-related components as possible, right? So if you've ever used a RAID controller, you know that it's a nightmare. So we got rid of RAID controllers. If you have ever kind of done like very, very large-scale service provider level switching, you know that like physical switching has a bunch of limitations, and so we do virtual switching on the hypervisors. And so these kinds of decisions about what we can do in software versus what we can do in hardware are really, kind of instrumental. And one of the kind of interesting side effects is that as CPUs get faster, we get to do more stuff in software, right? And there's also lots of cool stuff happening, in the software storage space, and there's just lots of really interesting stuff happening in the infrastructure space right now. And many of those are things like ASICs that you can write software for that are very kind of specific, and also kind of the new robustness, that has been found in things like software rate, right? So we feel really good about the choice to go with software rate. It's alleviated a lot of kind of issues that we had in the storage stack. And then, as I kind of mentioned, semi-related to kind of keeping data centers hermetic, entirely separate control and data planes is another kind of one of these principles. If you're familiar with the networking world, this has been a thing in networking for a very, very long time, right? You have a CPU that's slow compared to the fib, essentially. And then, so we try to separate the control and data planes entirely, right? So this means if the control plane goes down, if event scheduling stops, if the website is down or whatever, customers don't lose connectivity to their droplets, right? This is a really kind of obvious thing when you think about it, but it's also pretty easy to amalgamate the two into something that's less kind of failure robust. And then a final one, which is probably a talk in and of itself, is kind of, we value predictability over shine any day of the week, right? So there are lots of cool things happening in the space, but we've kind of made the decision, we've kind of gone all in on MySQL, for example, and one of the reasons for that is yes, there are cool things happening in the database space, but the operational predictability, the ability to learn and participate from and in the community, and things like that have really led to us, go heavily adopting both MySQL and Go, which some people might say is shiny, but has turned out to be one of the kind of best technical decisions I think we've made as a company, and a lot of our systems that we'll be talking about are written in Go. So I think it's been an incredibly powerful, kind of near systems programming language that has really enabled us to build a lot of the systems that we currently run in production. Does anyone have questions before I move on? Cool. So with those things kind of in mind, we'll move forward. So I'm going to talk a little bit about the kind of hardware that we have deployed. We haven't really ever talked publicly about this, so this should be good. So yeah, those cold storage systems that I talked about are these, for backups and snapshots and things like that. So those are 120 terabytes per node. So yeah, lots of storage. And we have this in-house image routing and metadata service that we internally call image management, which is written in Go, which is based off of the GFS paper, if you're familiar with it. So there's, I'm not really going to talk more about that. Mac actually worked on the initial version of that, so he can talk more about it. But the software that's running on top of those systems is written in Go, and we have petabytes and petabytes of cold storage deployed throughout our global footprint. Hypervisors, which are the actual thing that droplets run on top of, and hypervisors are also hermetic, right? So your droplet is kind of running on that one hypervisor. Have 2 by 40 gigabit Ethernet connections, 24 cores with hyperthreading, so 48 threads per node. A lot of RAM. I'm not going to tell you exactly how much RAM, but a lot. And then high-end kind of enterprise-grade SSDs. And then we have these kind of infrastructure nodes, but the hypervisors are really kind of the bread and butter, right? So as we build new kind of revisions to the hardware, those changes land in the hypervisors, and that's kind of where we focus our efforts in terms of understanding how the operating system and applications are interacting, understanding how the virtualization layer and applications are interacting, and all of those kinds of things. So that's kind of what the hardware footprint looks like. This is what it looks like in practice. This is so these boxes are pizza boxes. They're 1U servers. This is FRA1. If any of you have droplets there, this is the first podlet in FRA1. So yeah, you can see lots of servers. you can see, we have a lot of yeah, there's a lot of cables. I don't know, things just get plugged in. Yeah, we have a bunch of servers. You can see this black cabling is the fiber, the green cabling is the out-of-band network, and then obviously power distribution is red and blue, and orange for connectivity up to power distribution systems. So this is kind of I mean, they're much larger than this kind of one picture, but this is kind of what the back of all of the, our systems look like. So yeah, any questions about this stuff? Yeah.
How do you think you cool?
Fans. They're not super thermally dense, so there are 40 of them per rack, and we don't really have cooling problems. They're obviously drop floors and stuff, so there's a lot of ventilation, but they actually are able to get all the heat out. So yeah. And they, because they're hypervisors, they run like really, really hot.
Do you put those together yourself, or do you have a vendor?
Oh yeah, I build each of them myself. We have a vendor. We have vendors. We work with OEMs.
So you involved strip out the metal cases, because if you strip them out, then you get much more air circulation.
It's just not a problem that we have, so we haven't done it.
No.
There are a lot of problems with not having chassis, really, too. So that's something we have to do. Did you have a question?
Yeah, you get to show us the front so we can see the nameplates on them.
I don't have the front, and they don't have nameplates on them. They're major OEM supply. We work with several OEMs.
So you're buying these cases of one on top of the other.
Yes.
Oh, that's the need.
Well, in a rack, right? Yep.
So you mentioned that you don't use hardware RAID. Are you running into any performance issues?
No. So this is actually one of the most interesting things when we were designing the current hardware revision, is that So we had very high-end hardware RAID controllers before. The software RAID, well-tuned, is with the same disks 3.5 times faster. Like RAID controllers are terrible. Burn down RAID controllers, they're the worst thing ever. They're really, really bad. Yeah, so we have significantly increased performance. And one of the other nice things is if you've ever dealt with, there are only a very, very limited number of subsets of RAID controllers that support trim, right? So if you're familiar with trim, it helps clear out unused blocks on your solid state storage. And that was actually one of the main motivations to switching to software RAID, was to get rid of hardware RAID controllers so that we could trim through it. And it ended up providing a lot of other benefits. Rebuilds on RAID are also a lot faster. And Facebook in Linux 4.2 kernel, we don't run RAID 5 or RAID 6, but Facebook has been contributing quite heavily and has moved almost their entire fleet over to using software RAID as well. So I actually think the future is even further than software RAID, which is systems that are aware of the individual spindles, the individual disks that they're addressing.
ZFS?
Sure. Probably not ButterFS. That's about as far as I'll go. Sorry. It was a cheap shot.
Okay.
Yeah.
I was just about this. Are you using customized software RAID or
Official.
My bad.
It's mainstream Linux kernel.
Okay.
So it's MD RAID.
MD.
It's literally MD RAID. And it performs significantly better than hardware backed RAID. The other interesting thing is that one of the reasons that people always say to have hardware RAID controllers, which we found not to be the case, is battery backup units. But all of our systems have dual power supplies, so like if that happens, much worse things are going to happen, right? Like if we lose power to a rack, like the BBU is the least of our concerns. What's that? Yep.
And last question regarding RAID.
Yep.
What configuration are you using? 0?
I'm not going to tell you our RAID level, but actually it's published. It's RAID 10. I don't care.
Okay.
I forgot that it's on the website. But yeah, it's RAID 10.
Okay. Interesting.
one of the reasons that we use RAID 10, I actually at PuppetConf gave a talk about why we use software RAID. I've become like a software RAID evangelist of sorts. One of the other things about it is that, and one of the reasons that we chose to do software RAID is because it's much easier to understand how write leveling is affecting the drives in software RAID. So you can do all these things with RAID controllers, but you have to use Mega CLI, and like nobody needs that in their life.
Unless you're stuck with proprietary software that's bound only to the specific RAID controller. So.
Fair. In which case, you're probably already pretty sad.
Most of us are.
Yeah. So that's the data center. So just to kind of wrap up, so I just wanted to talk quickly about the kind of things that we have to configure on these systems before Mac start talking about kind of configuration management, directly related things. So, we kind of have the entire stack to manage, right? So we have everything from application configuration, or the application stack on a hypervisor, which is a combination of the management software and the virtualization stack. Runtime dependencies, service management. But if we start kind of from the lowest level, there are bugs in the Linux kernel. I'm not sure if you've heard, but sometimes we have to patch the Linux kernel. So we have to configure the bootloader and the operating system. DKMS is dynamic kernel module building. So if you're familiar with kind of the insertable module stuff in Linux, essentially what it does is it builds a new version of the driver each time you do kind of operation on the kernel. So if you upgrade the kernel, it will build a new driver against the ABI of the newly installed kernel. And then parameter tuning, right? Like there's a bunch of really bad defaults in Linux, and so we have to change a lot of the defaults to deal with different conditions that might happen, and also kind of tune the TCP stack and tune other things that drastically affect host performance. Then that's kind of the lowest level. Then and some of these things, these DKMS things are often for drivers, right? So in order to boot up the machine and get the NICs online, for example, we need to have a specific driver for those NICs already installed. So that's part of the server bootstrap process. Then on the system level, we have things like I need to install a new daemon or a tool or some service on the host, and then configure the kind of base system, right? The kind of base stuff that we require that has to get installed, right? So things like authentication, logging, security, and service discovery, things that we need to basically be able to bring up and communicate with the rest of everything and allow users to log in. And then we have application stuff, so like runtime dependency, service management. Obviously runtime dependencies, because so much of our stuff is in Go, is a pretty easy problem because we have statically linked binaries. So that's pretty cool. And then service management stuff, such as writing out the configuration so that the init system, we run Ubuntu, but so that the init system will start these new daemons. And then, as I said, virtualization, networking, and storage stack on hypervisors. Any more questions? Yeah.
Could you diverge into what specifically options you do to tune the kernel?
Let's talk after. There's a lot of stuff there.
Okay.
But yeah, I'm happy to share that stuff. It's a lot of things. So a couple of things. I'll just touch on the high level things. So the Linux TCP stack is built for the 1990s. I'm not trying to make this splash comedy about Linux, but here we are. It's really tuned for when people had base 10 routers that they would shut off at night. So there's a bunch of things that Linux does around explicit congestion notification and other things by default that are bad that we disable. Things like not saving TCP metrics. So if you go over a path that is congested, Linux will remember that for by default the next 1,000 times you connect to that thing, which means that when you, if you have some congested path to some, say, storage system, you end up in a position where the initial window size is extremely small, and then you have to kind of ramp up the window size over time, and so we would rather start it at the default window size. There are a number of storage tuning things. yeah, we can talk about it after. But basically, the entire Linux stack has to be heavily tuned in order to perform well.
Okay.
Yeah.
Do you run your own Linux distribution, or do you use?
No, Ubuntu. It's I will say though, it's very heavily customized, particularly in user space. So we build a lot of our own user space services. So an example of that is there's someone who works at DigitalOcean who's one of the maintainers of our syslog. And so we run a very modern version of our syslog so that we can get new features that he's integrating upstream into our syslog. We have similar things for lots of other kinds of services, things that we need to build to get newer features or to patch bugs. But we obviously are trying to get changes upstream as often as possible so that we don't have to maintain them ourselves forever. Yeah.
Are you on the latest release of Ubuntu?
Yes. The latest LTS release.
15.04.
No. 14.04.
Okay.
Yeah, I'm not that brave. That requires significant amounts of bravery. Not like on a desktop, but on a fleet of our size, like not having upgradable software all the time is kind of scary. But when 16.04 gets released, we'll move to 16.04 and 18.04 and whatever.
Okay.
And do you drop an image, or do you pre-seed?
We pre-seed. Any other questions? Yeah.
How would it take you to deploy 16.4?
That's a good question. So the most kind of intensive part of that is doing drive reporting to new kernel versions, right? So, for example, a storage driver that we use that we have a custom build of will require us to update, the code to match the new Linux API. One of the actually kind of interesting things about Linux is that, I think Linus might have kind of found God late in life in ABI maintainability. And so he's pretty crazy about making sure that the ABI stays the same. And so inside of Linux releases, the ABI has been extremely stable in the 3.x and now in the 4.x series. So once we move from 3.x, which is what we're currently on, to 4.x, which by the way is a really exciting Linux release, there's the number of kind of, particularly in 4.4 with eBPF, the number of really cool performance and tracing features that have gotten added to Linux in the past couple of years is really, really exciting. And we still don't have dtrace, but I'm okay, and we'll deal with it. Does that answer your question? So it will take some amount of time. TLDR. Yeah.
If you have trouble with the hardware, do you migrate machines off, or do you send a message?
It depends. It depends. So we do have a migration mechanism, but in other cases, if we need to reboot a hypervisor in a more limited circumstance, we'll just do it with customer notification, obviously. Yeah.
How often does your hardware die?
Never. Never. No. So are you asking completely die?
Yeah, not usable. You have to swap it out.
It's a very rare event. It happens often on the order of often maybe once a month. But when you have tens of thousands of machines, that's not very often by, occurrence.
Any problems with SSDs going on?
Yes.
Which hypervisor technology do you use?
We run KVM.
So why not VHOP? Because then you get dtrace and ZFS.
And yeah, we have hundreds of
solid
thousands.
kernel level API with FreeBSD.
That's fair. So that's the FreeBSD guy in the room. I actually know Sarah's really into FreeBSD too, so she's not the FreeBSD guy, she's the FreeBSD gal, and she's right there. So, but yeah, no. So FreeBSD and Beehive in particular is super interesting.
But it's nowhere near stable. I'm just.
It's not super stable.
To bust your chops.
Yeah, it's a valid question. That virtual switching layer is specific to Linux. Our customers are running Linux, so it's probably good that we run Linux. Although we do also offer FreeBSD, although it's not utilized in the same way as Linux tends to be across the system. Sorry. And yeah, there is a lot of interesting stuff happening in hypervisor land right now. OSX just got Xhive, and
Thank you to the previous meeting.
yes, thank you to the previous deacon again. And I think there are also, this is a big tangent, but I think there are also a ton of lessons for Linux to learn from the FreeBSD and Solaris communities, particularly around how the operating system should do containment, right? So one of the most compelling things to me about, well, it's less compelling to me about FreeBSD, honestly, because I think jails are not as good of an implementation as zones are, but I think that a zone kind of concept would be massively useful in Linux, right? So one of the interesting things that's happening in the Linux community is as we see this kind of container stuff take off, I think people are starting to realize that Linux maybe doesn't have the security facilities to support the kind of stuff that people are trying to do. And I think that the operating systems that have that kind of first level primitive of a zone or a jail are pretty far ahead in that game. And I think Linux will eventually have it once, but I think people are going to get really tired of C groups and namespaces with seccomp. And so when they do, I think finally there will probably be enough movement and enough interest to kind of have those kinds of high level, like contained root, contained physical devices stuff get put into the Linux kernel. Yeah.
LXC is a good start, but it's definitely no jails or something.
Yeah, and the thing that's interesting about LXC is like LXC doesn't exist as a concept in the kernel. LXC is an entirely user space concept that builds on top of C groups and namespaces, and so I really think that people at some point are going to really want a higher level of containment than what they're getting today. And we'll see what that stuff looks like. I think there's a ton of really interesting things that are taking place right now in the broader kind of kernel community and the container community as well that will hopefully push people to build this kind of first level thing into Linux. That being said, it's a gigantic lift, right? If you talk to anyone who was at Sun when they added it to when they added it to Solaris before it was Open Solaris, they will tell you that they basically rewrote the operating system. And I don't know if Linux is ready to do that. So we'll see.
This is call it hypothetical, but you ever see supporting deploying unikernels onto
We'll see. I don't think that the well, I don't want to make a statement on the behalf of DO about unikernels, but I'll speak on my behalf. I'll say what I kind of think about them, which is that I think it's an interesting technology, and we will see where it goes. Yeah.
Has there been interest, I guess, for other types of operating systems, such as Windows or OS X or DO?
Yes. Yeah. You can't. So you're not allowed to. You're not allowed to virtualize OS X except on Apple hardware. So that's probably not a thing that will ever happen. Anyone else? Awesome. Thank you. I will now welcome up Mac. Mac's a senior software engineer on the delivery team, and he'll be talking a little bit about Chef.
So like Sam said, my name's Mac. I'm an engineer here at DO. And I want to talk about Chef. And not so much about Chef, so if you're not familiar with Chef, not a big deal. It's more going to be about kind of an idea of a growing code base in a growing company and how we manage that at DO. And some things we've learned along the way that have definitely helped. So that's who I am. Like Sam said, I'm the delivery engineering team, so we're a team responsible for a lot of the kind of dev to production part of software development. So we love Docker, obviously, clearly, but really it's more about like CI, build, kind of that consistency layer, some service discovery primitives, deploy orchestration, that type of thing. And so we'll kind of get more into that later. So for now, let's talk about Chef. So I kind of want to get an idea of where everyone's at, and so can I get show of hands for like people that have written Ruby? All right, so it's like most people, makes sense. Who has used some sort of configuration management, Salt, Ansible, Chef, whatever? All right, that's pretty much everyone. I feel sorry for all of you. And who has written Chef? All right, it's still pretty big. I really feel sorry for you. But yeah, so like feel sorry for myself. So like Sam said, we actually do have a lot of Chef. We write a lot of Chef at DO. And this is really shared between all of our teams, and I'll get more into that in a little bit. But yeah, some things we like about Chef, it's a really active community, which is a great thing for any open source project, obviously. Feature rich, all kinds of amazing providers, either built into the standard, kind of the standard Chef library, or via the community, which is, again, mountains of resources, tutorials, communities, meetups, etc. And again, it's written in Ruby, which we have a lot of elsewhere, and so it's a big plus to have kind of our configuration management in Ruby. Gives a lot of flexibility, but that's kind of also a minus. So we're also devoured by Chef, and so Chef definitely subscribes to the Tim Toady model. Anyone's not familiar with that? It's the Perlism, where there's more than one way to do it. Ruby also subscribes to this. Well, I'd never heard Tim Toady. Anyways, but Chef definitely subscribes to this. There are so many ways to do so many different things, which is great sometimes. Sometimes you really want that flexibility. Other times, you just don't, because it introduces a whole level of complexity that's just not necessary. So, another big minus to Chef, it's a relatively unique development environment. If you're familiar with Ruby, it's not too bad. It's just a couple extra gems to install. But if you're not familiar with Ruby, which not everyone is, it's a little bit daunting. You have to install Ruby, which is like, a day and a half, depending whether or not you know. So that's like a big minus. And then we use Test Kitchen, and specifically Server Spec with Test Kitchen, and then Chef Spec for writing tests. We love tests. And again, it's a slow OODA loop, which I'm going to totally butcher this, but it's like observe, orient, decide, and act. It's the idea of just the feedback mechanism for when you're developing software or making any decision. The shorter it is, the quicker you can come to like a very good solution to the problem. Cool. So, kind of our Chef repo. Sam gave numbers on hardware, which is cool, but software is pretty cool too sometimes. Yeah, so Chef's been pretty active at DO, especially picked up around 2014. We do have a single Chef repo, so we have the idea of cookbooks all built into one repo, which is a plus or minus depending on how you deal with it. We have about 70 committers at this point to our Chef repository, 4,800 pull requests, which is pretty amazing because a lot of those actually came about in the last year, maybe a year and a half, and then 28,000 commits. So not the biggest thing in the world, but definitely have had some issues due to it. Great, and so kind of talk about these issues. So there's been a lot of friction, and so as DigitalOcean grew up, Brian kind of got into that. He was employee 40, I think I was in the 20s or 30s. Now we're 200 plus, so we have a lot more engineers, and a lot more people started writing Chef, which is great because now we have a lot more contributors to our project. But it's also a minus because it wasn't really meant for that at the time. The way it was originally set up was definitely set up in a way that made it hard to onboard for new engineers. So some of those things were like, we had inconsistent reviews. So you might submit a PR, you might get 2 or 3 reviewers, depending on what the PR dealt with. One of those people might say one thing, one of those people might say something else, and now like who's right? They're both engineers that have been writing a lot of Chef, have years of experience writing configuration management. They're both probably right, but ultimately at the end of the day we need to kind of come to a solution and get the code out the door. So message development environment, went about that a few minutes ago. So same idea, just hard to get set up. Ruby is not user friendly unless you set it up about 10 times, and even then you're probably going to have to recompile it next time. And then CI for us was actually really slow. This kind of had to do with the mono repo idea. You might test a lot of cookbooks, which take a while. Part of that also has to do with the Chef kind of ecosystem for testing. So like Test Kitchen is really cool because you get this nice integration test, but it takes a while. You have to wait for a VM to boot up, wait for a Docker container to boot up, however you do it. So that was those are kind of 3 big points. So now some solutions to these problems. And so these are kind of really generic solutions. We applied them to the Chef repo, but I think they could actually be applied to all of our repos, and they actually are applied to all of our repos at DO. So maybe we'll find something that helps out. So at a high level, it's going to be a style guide, some common development environment, an owner's file, which is something I'll get into, and then CI improvements. So style. Style is super important when it comes to code. We all want to look really cool. That's all that really matters. Yeah, this really, style is kind of an overloaded term here. It's really not just about how it looks, but also what patterns you're using, what of that Tim Toady idea are you choosing with that? And so we built this out of the common reviews, and so every time you would get that idea of like, oh, I've seen this pattern 3 or 4 times, this person uses a provider this way. It seems like a pretty good pattern, let's adopt it to our style guide. And so now it's actually like hard-coded, you know where to find it, you can look it up on your own, you don't need a review to find that little tidbit of hidden information. It's also important to note that it's a style guide, not a style rule, so if you need to deviate, you deviate. Like that's part of software, you're gonna have to change whatever you set out to do from the get-go. And then it's also really important to not just have the like what to do, but the why to do it. Why to do it's just as important. It helps people remember for the future, but also like helps everyone learn. And then also builds a place for discussion for like, I want to change this because, which is we've done many times. Our style guide's actually checked into the repo. And so here you'll see kind of an excerpt from it. It's just some markdown, obviously. And so to edit the style guide, you just open a pull request like anything else. And so here it goes into like, how did you get commits? Because of the mono repo idea, it actually becomes a little tougher to review PRs because the PR might have to do with a cookbook that you know absolutely nothing about, you don't care about. So we have some kind of guidelines to make it very obvious what you're changing so that the review becomes very easy. Again, another great example of just what it looks like in practice. And some code cut out of like, here's how to write some tests to encourage best practices of like, we like to write tests. Cool. So development environment. It wouldn't be a talk without having Docker in it. So I wanted to include Docker. But we actually do use Docker for our development environment, which is weird because I wouldn't have said that too long ago, but that's where we are. One thing that's really nice about it is actually it is consistent, which is great. And I say consistent because it's actually the same way we do our CI. We use our same Docker container that you use for development and CI. So it's if you're using what CI is using, then you're going to have a much better experience of like, my tests are not passing on CI, but they're passing locally. What's going on? So that kind of eliminates that problem. It also means I don't have to debug people's Ruby setups, which I don't know if you've ever had that experience, but it is literally the worst thing ever. So like, just get away from it immediately. Yeah, it's awful. And it's, especially when you have OS X and Linux, just stop. Yeah, and so a big key component of this is minimizing the time to run, like time to run your first test. No one wants to sit around and wait for like gems to install before you can run RSpec. Like that's just, no one's gonna run tests then. So we want to encourage people to run their tests to make it easy to run your tests. And then again, encourage the best practices. So if it's easy to run your tests, you're gonna run your tests and we'll see if they pass, we'll see if they don't. So here's a demo. Awesome, it works. Yeah, so there's just a script checked into the chef repo that will pull a Docker container, set up Docker, and there you go. You can just cd it around your cookbooks or whatever, auto review. We're gonna run the spec. Takes a while because it's Ruby. There's a VM. It's whatever. It'll happen. I promise.
No Fakiri has to go on.
Yeah, exactly. No Fakiri. There we go. It happened. And then we do kitchen tests. So both things work. We actually use Kitchen DigitalOcean, which is an amazing test kitchen plugin for booting the DigitalOcean VM. That's shocker. So yeah, that was our demo. And so but that's something that any developer that has Docker installed locally can do. And it means zero setup for Ruby. So you can commit your changes locally, run your script Docker env, and be in a VM, or not a VM, a container that you can then muck around with RSpec and Kitchen on, which is awesome. Go for it. Okay, cool. So that was our consistent environment. Now talk about the owner's file. So owners is definitely not a unique concept DO. It's just our implementation of this idea of owners of the code base. And so it is actually just done in practice as an owner's file. And so owners are specifically teams, not individuals. There are individual owners, but we try to err towards teams because obviously we want the bus factor to be high. It is represented alongside the code, so it's not a separate mapping. There's actually, you can look locally like, who owns this code and who can I go bother? Because they can tell me what I need to do. They're responsible for reviewing, approving, and kind of also keeping the code base up to snuff, up to par. And then this is all enforced via automated tooling. This last line is actually really important, and I'll get to that in a minute. So this is a bad example. I'm sorry. It looks really bad. But the important thing, though, it's just it shows the tree of one of our cookbooks. In the cookbook folder itself, so cookbook Kubernetes, we have an owner's file, and inside that file, it actually references my team at DigitalOcean Delivery. And so there I am, terrible picture, opening a PR on GitHub, and immediately we have Sammy letting us know that DigitalOcean Delivery needs to take a look at this according to the owner's file. So this actually has been a huge boon because it means we can segment out parts of our code base, which makes it really easy for people to get involved and also to know who to go talk to if you want to make changes. Great, and so the point about it's important to have it automatically enforced. So this is an amazing slide from Beekeepers. I think this is his Twitter handle, Brandon Keepers. But yeah, so it reads, we are more receptive to feedback from pedantic robots than pedantic people, and robots are much more reliable. And that's 100% accurate if you've ever given like a code review. People do not mind if like RuboCop or someone just comes in and just vomits all over their pull requests. But if you come in as an individual and you vomit all over the pull requests, it's gonna like, there's gonna be tension. Which is like, we wanna avoid that. So this is just amazing. Yeah, so Sammy's our pedantic robot in this case. Great, and so kind of the last point was we want to speed up CI. And so we use drone.io for CI. We use the open source version, not their hosted version. It's been amazing to work with that project. The committers are super receptive. I was up at 1 a.m. last night debugging a problem we were having, and they were able to submit a push that fixed our problem before the morning. Like that's an amazing thing to have in an open source community. So the way we actually did this was solved with the consistent development environment. So everyone hates waiting, so we want to make it fast, which means caching everything we can cache locally. So one of those big things is like, bundle install takes a really long time because no Fakiri has to get installed. So by creating that development container, we actually ended up caching a lot of those things anyways. And by using that in our CI, we just got the benefit out the gate. So it actually was like 100-factor decrease in time to like the first test running, which was pretty amazing. And people were like, this is awesome. This actually spawned a whole chain of changes throughout all of our code bases where our CIs were, a few minutes, not like crazy high in some cases. Chef was probably the worst abuser, down to seconds to the first test. And it's all because of just caching what you can, testing actually what you need to test, and ensuring that your tools are doing a lot of hard work. Great, so this is my wrap-up slide. That's the idea of like, you really want to be very consistent with your reviews, which is where style guides come in. You want to make sure it's an easy to onboard system, so that's where you want to have a consistent development environment. You want to make it easy for people to know who the heck owns and maintains all your code bases. Even if they are separate code bases, it would still work. Our monorepo is a little different. Our Go is the same way as a giant monorepo, or it's not giant, it's large monorepo, but it's still segmented up into different owners. And then finally, whatever robots you're going to have enforcing it, make sure they do a good job and they do it pretty quickly. And so thanks. Again, Mac, if any of this interests you, please come talk to me. I'd love to talk more about it. And I'll take any questions if you guys have any questions.
Do you guys have, besides having a style guide, you have like automatic code formatters? Or is that up to the individual developer to figure on their own? Yeah, so our Ruby, as part of the style guide, does specify the formatting. It's up to the user to actually do the formatting. It's a shortcoming, not really of Ruby, but it's a shortcoming of like the Ruby standard library or the Ruby, what everyone's used to. Like our Go stuff is obviously all Go functed, no problems there. But Ruby's a little bit tougher. But yeah, we do outline like this is how it should look, but we are going to put in not RuboCop, I forget the Hound, and Hound does like Ruby formatting. And so again, another robot that will enforce the idea of here's what it needs to look like. So, cool.
So how much do you hate Git submodules at this point?
So we do not use Git submodules at all.
So you have a monolithic Chef repo and don't use submodules.
Correct.
Who do you use?
Correct. So most of the time it's just not submoduled. So it's a reference essentially by maintaining the Git reference, but not under .git. So it looks like just a folder, but you can still just move back to manage I want to now look at the actual upstream of this and pull it. So it's a little bit more overhead, but it does avoid the submodule hell, which is something we just didn't want to deal with at the time.
Have you done subtree?
So we have not.
Some trees can.
Yeah. Okay. Well, that's pretty cool. There's also I forget there's another optimization that actually makes it a lot better, but I forget what it's called. And we actually have a similar problem with our Go stuff as well. It's a pain. Most of our chef stuff's actually in house. We use quite a bit of the community, but I would say at this point the majority is either heavily altered, just because of kind of the environment Sam was laying out earlier. It's a little unique than what a lot of people plan their chef cookbook to be used for. Sure. Sorry. White shirt. It stood out. I'm sorry.
So, I've seen some slides that really correlate to the reality at some point. So, how much of the data is from the code?
So,
like data back, or certain values, like NYC3 is probably like the data, the actual variable in the code. So, how much those are spoken?
Sure. Yeah, so our data bags were separate at one point. They're now embedded in a lot of cases. It's not our only source of data. Part of our style guide actually goes into that. We've had different generations of DO engineers, right? And so the current generation is very focused on as much separation from kind of the global mutable state of like the node object. And so we actually use data bags a lot. And those are just store things like our regions. They store things like what configuration per region to make the service per region paradigm that Sam had mentioned a possibility. And so it depends. Most things are checked in alongside just our data bag, but it is segmented into its own section of the chef repo. And so it's like we have a data bags filter that has a different hierarchy. So you can imagine it as something we could just pull out and put somewhere else, but for now it's just part of our chef repo because it is just part of chef.
Mm-hmm.
Yeah. Cool. Let's go to the back, because I feel bad.
How much of the local development is happening inside of a Docker container, and how much of it is happening, like what tools do you install on a OS 10 machine versus the container?
Yep. So the Docker environment's relatively new. It's had pretty good adoption. I've actually had people be like, "This is amazing," which has like made my day. And so, but I would say it's at this point it's probably something like 80-20, 80% of people that already had Chef environment set up. It's more for people that are new to the company, joining the company, have never written Chef before. It's just a really easy way for them to get set up. I mean, there's some minuses, you can't use Vagrant. So if you want to have a local VM for whatever you're working on, it's not something that's currently offered by it. Some people really want to have that nice, easy spin-up time of like a VM locally versus a 1 minute for the droplet. But trade-off. So yeah, it's an encouraged environment. It's not necessarily required. So if people want to set up Chef on their own, go for it. But I'm not going to debug your Ruby environment. It's basically how this came about.
Right. So to clarify, then the containers are running on droplets.
Yes. Oh, so the containers themselves are running on could run on droplets. They are. It assumes you set up your Docker environment. So if you Docker machine locally and you set it up in a Vagrant VM or whatever, or a VirtualBox VM, that's up to you. If you set it up on a droplet, that's also fine. It does have some shortcomings because it has to talk to our internal infrastructure, like our Burps API is hosted internally, things like that. So it needs to be part of our VPN in some way, which is a possibility. We have some internal droplet type ideas, but generally speaking, it's usually out of the developer machine on the VirtualBox.
Okay.
Cool. Sorry.
I think that's kind of like the last mile where you now past CI, it's now new updates are there, and they got to roll it out to machines. Is that all VMs and build up from scratch?
So that's a tough question to answer. So last mile is actually really what makes the Chef so hard, and so we try to tackle that by having really encouraging testing, a lot of testing, and our integration tests are actually reasonably accurate to what you're going to experience in the wild. But there's still that idea of, okay, I'm green, I got a +1, this other person thinks I'm good, so I should think I'm good, so let's just merge it and see what happens. And so the way that works is it's generally based on the impact of the change. So we have some changes that are relatively small, like you have your service running, it runs on one node somewhere in our infrastructure. Not a big deal. If it breaks, only you notice, not who cares. You care, but I don't care. But we have the other changes that are okay, well, we need to tune this Linux kernel module, or we need to turn this Linux kernel setting for ARP. And that's the entire cloud. And so that change is scary. Skittles is scared of that change. Or, sorry, Sam. Sorry, my bad. Sorry, Sam. So, but that the way we accomplish that is by writing a lot of our code that's checked into the Chef code base is actually written with that in mind. So if you know your change is going to be a significant impact like that, then it's probably better that you write a little bit harder code in terms of maybe you only roll it out to 10% of the nodes. Like, it's kind of the idea of, as a software engineer, you need to judge how bad or how good this is going to be for you, and decide how much you want to get paged at 2 a.m. And so,
Do you guys have separate tooling for that rollout process then?
So we do to some extent. We do have like a staging environment, and it does reflect production pretty well. But there's nothing like production. There's nothing but production like production, whatever the saying is. So there's still that. You still, no matter how good your tooling is, you're still going to have that little bit of like a nitpick in the back of your mind. So we do try to minimize that as much as possible. But if anyone has some really amazing tools for that, we would love to talk.
Yeah, you hire Samuel L. Jackson, he says, hold on to your butt, and then roll it into production.
So, man.
And hope the velociraptors don't eat you.
Butts.holdings is the best website on the internet. I don't know if anyone knows who runs that site, but like on a daily basis, I link to that site all the time. So, yeah, I mean, it's definitely a little bit of a daunting task. It does come down to the impact, and we have some very talented individuals that have gone through it a little bit, and that's kind of what we lean on in terms of like how do we make it as healthy as possible because we don't want to interrupt our customers' days.
Do you have any tooling that lets you kind of understand in advance what the impact of the change is going to be?
Yeah, so we do have, we rely pretty heavily on knife search to Chef Server. So we do use Chef Server, not Chef Solo. And so we make use of that in terms of to gauge the impact of changes and to verify like, okay, well, what's this recipe running on? What's going to meet this case? Our automated tooling is mostly kind of centered around chat ops, and it's something that we're working on pretty actively. But again, that's kind of where hopefully my team comes in, is we get to kind of measure that impact, make it easier for developers to roll out to larger pieces of the infrastructure. And part of it is also removing a lot of responsibility from Chef, because ultimately it's not a great tool for that. Cool.
How do you scale Chef?
What?
How do you scale Chef? I mean,
How do you scale Chef?
Yeah.
Oh boy. That's like a whole talk in itself.
Yeah, I know.
Yeah. So our problem, we luck out in that a lot of our infrastructure is relatively static. So we have the hypervisor, which is the largest piece of our infrastructure. It's also, like I said, relatively static. We do make changes to it. We don't have to make changes to it every minute, every second. So we do have kind of relatively long Chef client, like a Chef run interval. And so that helps us just in terms of scale. Is the scaling problem then becomes just, what is that? Like, it gives us a lot more runway. And so overall, our biggest bottlenecks have been around attributes, and so we use a whitelist attribute paradigm that's pretty common. So we just limit that because we don't want to knock over Solar or whoever does the caching on Chef for searching. So that was our biggest, so far that's been our biggest bottleneck in terms of how Chef scales for us, has been the searches. And so how we scale that is we're trying to move away from it. So we're introducing service discovery primitive, we use console, and we want to move a lot of what represents Chef search to something else, and that way we can move away from Chef server ultimately. So in my opinion and a lot of other people's, the way to scale Chef is to stop using Chef server. So, that's the only way. Cool. All right, anyone else? Oh, yeah.
So getting rid of the Chef server meaning download the cookbooks and apply them locally.
Yeah, exactly. Apply locally, have no reliance on data bags or Chef searches, things that have to check the Chef server.
Yeah.
Okay. Yep. Cool. All right. Awesome. Thanks, everyone.